Welcome to linear programming. A linear programming problem, or LPP, is the one in which we try to find the maximum or minimum value of a linear function subject to the constraints determined by a set of linear inequations with variables as non-negative. For example, maximize z equal to 60x plus 15y subject to x plus y less than equal to 50, 3x plus y less than equal to 90, x and y greater than equal to 0. This is an LPP with z equal to 60x plus 15y as the objective function and 1, 2 and 3 as the constraints. X and y are called the decision variables. More often than not, we need to assume decision variables and come up with the objective function and constraints on our own using information given in the question. Such problems are most conveniently solved using the graphical method. The common region determined by all the constraints of an LPP on the graph is called the feasible region. The feasible region is said to be bounded if it has definite boundaries on all sides or it is a closed region. If the feasible region extends indefinitely in any direction, it is called unbounded. If the feasible region is bounded, the maximum or minimum value of the objective function must occur at one of the corner points. However, if the feasible region is unbounded, the maximum or minimum value may or may not exist. If it exists, it must occur at the corner points only. Things will get clearer when I start solving questions in the subsequent videos, in which we'll be discussing 4 different types of LPPs: general problems, manufacturing problems, diet problems, and transportation problems. Before we get into solving LPPs, let us revise how to solve linear inequations graphically. Let us solve the linear inequation 3y minus 5x less than 30 graphically. Given inequation is 3y minus 5x less than 30. The first thing that we need to do is plot the corresponding equation. Corresponding equation is 3y minus 5x equal to 30. When x equal to 0, 3y minus 5 times 0 equal to 30 from equation 2, or 3y equal to 30, or y equal to 30 divided by 3 equal to 10. Hence, line 2 cuts y-axis at the point 0, 10. When y equal to 0, 3 times 0 minus 5x equal to 30 from equation 2, or minus 5x equal to 30, or x equal to 30 divided by minus 5 equal to minus 6. Therefore, line 2 cuts x-axis at the point minus 6, 0. This is the point 0, 10, and this is the point minus 6, 0. So this is line 2. Note that we could have plotted line 2 by taking x equal to 0 and x equal to 1 and calculating the corresponding values of y using equation 2. Now line 2 divides the xy plane into 2 halves. One of these halves will satisfy the given inequality, but how do we decide which half? Take any one of the 2 halves and choose a point P with coordinates alpha, beta on that side of the line. Check if x equal to alpha, y equal to beta satisfies in equation 1. If yes, the entire half on the side of P will be the solution region. Otherwise, the other half will be the solution region. Usually, origin is taken as the point P because it has the simplest coordinates. But this is only if the origin does not lie on the line. In cases where origin lies on the plotted line, any point except the origin can be taken as P. In this question, origin does not lie on line 2. So let's check in equation 1 for the origin. Putting x equal to 0, y equal to 0 in 1, left hand side of 1 is equal to 3y minus 5x equal to 3 times 0 minus 5 times 0 equal to 0, which is less than 30. Therefore, origin satisfies the given inequation. This implies that the side of the line containing the origin is the solution region. So the solution region is this shaded region. Since the inequality is less than and not less than equal to, the plotted line is not included in the solution region and is hence shown as a dotted line. Note that what we just solved was a question of inequality. It was not an LPP. In an LPP, there is an additional constraint according to which the variables have to be greater than equal to 0. So in that case, we would only shade the region which has values of both the variables as greater than equal to 0, and that shaded region would be called the feasible region. Let us now discuss the shortcut method to solve the same question. We plot the line as before, but instead of checking the inequality for origin or any other point to get the solution region, we get the solution region using the following rules. In the inequation, if the term containing y is subtracted from the term containing x, x becomes the governing variable. If the term containing x is subtracted from the term containing y, y becomes the governing variable. If the term containing x is added to the term containing y, you can take either x or y as the governing variable. If the inequality is less than or less than equal to and the governing variable is x, the solution region is to the left of the plotted line. If the inequality is greater than or greater than equal to and the governing variable is x, the solution region is to the right of the plotted line. If the inequality is less than or less than equal to and the governing variable is y, the solution region is below the plotted line. If the inequality is greater than or greater than equal to and the governing variable is y, the solution region is above the plotted line. Once you practice some questions, these rules will get registered in your mind automatically. Coming back to our question, the inequality is less than and the governing variable is y, so the solution region will be the half below the plotted line, which is this shaded region. As in the previous method, the plotted line will be dotted because the inequality is less than and not less than equal to. Let us solve another example in which the origin lies on the line. Let us solve the inequation x minus 2y greater than equal to 0. Given inequation is x minus 2y greater than equal to 0. The corresponding equation is x minus 2y equal to 0. Let us plot this line. When x equal to 0, 0 minus 2y equal to 0 from equation 2 or y equal to 0. Therefore, line 2 passes through the origin. When x equal to 2, 2 minus 2y equal to 0 from equation 2 or y equal to 2 divided by 2 equal to 1. Therefore, line 2 passes through the point 2, 1. This point is 0, 0 and this point is 2, 1. Therefore, this is line 2. The governing variable is x and the inequality is greater than equal to, so the solution region will be to the right of the plotted line. Since there is equality sign 2 in the inequality, the plotted line is included in the solution region and we show it by a solid line. In the next video, we'll solve questions on LPP, and as I said, that'll make things clearer for you. If you like what you saw, don't forget to hit the subscribe button. This is Abbyshek Chandra signing off. Take care.